All right, factoring objective. Students will know the definition of terms, coefficients, factors, and expressions, and be able to factor using the distributive property. Mainly, we're going to be doing the distributive property backwards. So I have this diagram here. Things are all labeled with pictures and arrows and everything. It says use the diagram to the right to match each definition with the correct word. So I want you guys to go ahead and try that. I'll give you guys a few minutes, so you're going to want to pause the video, but just try it, and then I'll put the answers up there in a second. Okay, so let's go to the first one, expression. Expression here looks like a whole bunch of terms. This is a minus sign and an adding sign, so they're adding or subtracted together. So let's see if there's something that seems like that. A single number or variable, no. Multiplied together, no, that's not it. A fixed number on its own, no, that looks like that's going to be a constant. So we know that b is constant. We'll put that in there, because see how that's a number on its own. Let's keep looking for an expression, though. Says that two things are equal and uses the equal symbol. No, that'll be something else. We'll look for that in a second. A number used to multiply a variable. Oh, well, look here. If m is a variable, 7 is the number used to multiply a variable. That's a coefficient. So we could go ahead and label that as a coefficient. We'll get back to that later. Okay, E, a symbol, usually a letter that represents an unknown quantity. Isn't that a variable, right? M is a symbol or a letter that represents an unknown quantity, so that's a variable. Looks like we're answering all of these pretty easily. Okay, a mathematical phrase that contains ordinary numbers, variables, and operators. This is a mathematical phrase. That's the one we were looking for. So that is F. An expression is a mathematical phrase. And that makes sense, right? Expression, a phrase. It's just in English, it's something that you say, right? So that would make sense. Okay, the next one is equation. Oh, we saw that one somewhere. Here it is. It says that two things are equal and uses the equal symbol. That's an equation. So that's C. Okay, and then we already said that variable is E, constant is B, coefficient is D. So term must be A. Let's see. Either a single number or variable or numbers and variables multiplied together. And look, that's exactly what they circle as a term here. So yes, that's a term. So now we have some basic framework, some vocabulary to look back on as we go through more and more questions. Especially some of the questions you're going to see on Con, they're going to be using this vocabulary, and you really need to know what they're talking about. Okay, so now that we've defined some vocabulary, let's practice factoring some expressions. Factor the expressions using the distributive property. Now let me show you what I mean. When I say factor using distributive property, I'm saying there's something that I can multiply that is multiplied into both of these numbers that I could then factor out or kind of suck out. So what's a number that goes into both of these? Well, I quickly see that 5 goes into both of these. So I'm going to write 5. And if I was to take a 5 out of 55, I would have 11, right? 55 divided by 5 is 11. And 35 divided by 5 is 7. So that's how I could rewrite that expression by factoring it using the distributive property. So these next two are similar, only they have variables in them as well. So I want you to go ahead and take a look at this one, see what you can pull out of it, and I'll go back and explain both of these after you've tried them. So go ahead and pause the video and try them both. Okay, so I looked at this and I saw, you know what, I think a 3 can go into both of these, but I also saw that a 6 can go into both of these, so I took a 6 out. When you take a 6 out, you're left with 2x plus 15, and there's nothing else that you can factor out of both of those terms using distributive property, so I'm done. Over here, though, I said, you know what, I could take a 6 out of both of these numbers, so I pulled a 6 out. I also noticed there was at least one x in each term, so I pulled out an x. When I did that, I would have 4x plus 6 remaining on the inside. Now, right away I noticed, you know what, I could take another number out of these two. I could take a 2 out. So I did it again. I did 6x times 2, 2x plus 3. Well, 2 times 6 is 12, so I have 12x and 2x plus 3 in the middle. And now there's nothing else that I could take out. So I'm done. Now, I could have saved myself a lot of trouble if I would have just noticed from the very beginning that I could take a 12 out of both of these numbers, a 12x actually out of both of these terms. That would have led me go right to the solution, but I just didn't see it right away, and that's okay. I can just keep going until I'm down to something that I can no longer factor. Okay, that's it for this video. Really simple video just about how to factor using distributive property.